Thank you all for joining us today. I've spent over 15 years in manufacturing and utilizing 3D printing to get products out of the market and into your customers' hands as fast as possible. I wanted to create this webinar series to ease the crippling slowdown caused by COVID and the COVID bottleneck, Markforged, the only continuous fiber 3D printing process, allowing you to quickly incorporate fiber into your development parts and end-use systems. Andrew will walk us through the technology while reviewing case studies that focus on applications and materials, just to kind of help, drive home how this is going to help you at your facilities. Let me now turn this over to Andrew Marsban. He is our applications engineer here at Saratech. Andrew, thank you so much for joining us today and teaching us more about Markforged capabilities and applications.
Thank you, Nicole. Yes, good morning, good afternoon, everyone. My name is Andrew Marsban. I'm an additive manufacturing engineer with Saratech. I do a lot of 3D printing. I live and breathe 3D printing. I install machines, service machines, set up prints for customers, as well as design for additive manufacturing. I've been working with 3D printers for over 5 years now, so I'm very excited to get started. So let's talk about composite materials. So what is a composite material? Most of you probably know composite materials combine multiple materials to achieve better properties. There are all sorts of composites. Today, we're going to focus on fiber reinforced composites. So fiber reinforced composites, you essentially have your matrix material and some sort of continuous fiber to create your composite. The great example of this is going to be carbon fiber, which everyone's familiar with. Now, composites basically take two materials with different properties. So in the case of carbon fiber, it's a fiber, it's flexible. You wouldn't think of it as load bearing. And then you have epoxy resin, which is very heavy. When you combine these two, the end result is an extremely light, extremely strong and rigid material that's more rigid than the fabric, lighter than the resin that it's made up of. So why do we use composites? Well, composites are used to give us better product performance. We use it to lower the weight. So in the case of aircraft, lower weight means less fuel burn, saves money for the airlines. For cars, we use it to reduce the weight, which gives us better acceleration. Boats used to be built out of wood, which was a very time-consuming, expensive process. Now using a fiberglass composite, we can make the process much quicker. So composites are used in so many things today, and we really like them because they just are able to improve performance in so many different ways. However, there's a trade-off, of course. Making composite parts is not always easy. It's a tricky process, requires specialized tools. You have to have very experienced fabricators. And then there's a lot of post-processing that comes afterwards. You have to trim edges, you have to sand things, and it's not cheap either. There's a lot of sunk costs. You have to create molds and specialized tooling. So there's got to be a better way. And thankfully, there is a solution. So Markforged is the leader in composite 3D printing. They make the hardware, software, and materials for their line of 3D printers. And Markforged recognized the issue with making composites, and their solution is an ecosystem that combines robust hardware, easy-to-use software, and high-quality tested materials that leverage the fused filament fabrication, also known as FFF or FDM, which is trademarked. But they use this process to extrude plastic as well as continuous fibers from a separate nozzle to make a single composite part. We'll see some examples of how this is used, and we'll also see how easy it is to implement this technology for your business as well. So how does the system work? Well, as I mentioned, there are two nozzles, and if you can see from the image here, we have the nozzle that extrudes the plastic, which is over here, and what that'll do is it'll lay down the matrix. Recall we said the matrix material, which is the base of the part, and then there's a second nozzle that lays this continuous strand of fiber in the part, and there's a cutting blade, so basically it'll route the fiber throughout the part, cut it, and then go on to the next layer. So this fiber is actually encapsulated in the part. It's not like a discontinuous fiber. It's one strong fiber. So I mentioned the matrix material. So we have different matrix materials that Markforged offers, and this is their Onyx family of materials. And it's their own proprietary blend of basically chopped carbon fiber and nylon. So a lot of people will advertise 3D printing with carbon fiber, and what that is very similar to the Onyx, where you have your thermoplastic and then some sort of powdered or chopped carbon fiber. What that does is it adds a little bit of stiffness to the nylon or to the thermoplastic, but it's not a true fiber reinforced part because you don't have very long fibers. So Markforged offers their Onyx line of material, and they also offer just a plain nylon as well. And here are some of the use cases. So we have our Onyx material, which is that go-to material. It's very strong compared to just regular nylon, has very high dimensional accuracy, and has a very beautiful surface finish. There is a variation of that that's called the Onyx FR, which is flame retardant version. It's UL 94V0 rated. And next, there is a ESD, electrostatic dissipative version, which is great for electronic applications. We'll see a couple applications where it's used in electronics manufacturing. And then lastly, there is the nylon, which is just a plain nylon, doesn't have that chopped carbon fiber in there. So it's not going to be as stiff, but if you're working with very high polished surfaces that you don't want to mar them at all, nylon may not be a bad choice. Onyx on its own is non-marring. It's very good to use for work holding, but if you do have something that's very finely polished, you might want to consider nylon instead. So let's look at the material properties of these materials. So you can see here we have our nylon and ABS, which are typical 3D printing materials. ABS is kind of the legacy material that a lot of 3D parts have been made with over the years. However, we can see the strength of Onyx with that chopped carbon fiber increases quite a bit. The Onyx ESD happens to be even stronger. Some of the additives that they use to make it static dissipative also increase the stiffness and strength of it. So if you have a very, very high strength application, then Onyx ESD may even be the best choice. But Onyx, again, is our go-to material here. So that is the base material that we talked about, or the matrix material. Now we need to talk about the continuous fiber, or the fiber reinforcement. Markforged offers 4 different fibers. That is going to be carbon fiber, fiberglass, a high strength, high temperature version of the fiberglass, as well as Kevlar. So as you're familiar with, carbon fiber has a very high strength to weight ratio. You're going to want to use this in your cases where you need maximum strength and weight is at a premium. So that's when you're going to want to use carbon fiber. Fiberglass is more cost effective. It's much heavier. So if you have an application that needs to be strong, but you're not necessarily worried about the weight, fiberglass is a good option, as well as the high strength, high temperature version of that. We'll see one case study where they needed to use the high strength, high temp fiberglass. And then last but not least, we have Kevlar, which is very tough, impact resistant, and it deforms rather than fracturing when it yields. So you may want to use that for certain cases. So we can see here the properties of these materials, and this is just the Onyx on its own, followed by Onyx reinforced with fiberglass, Kevlar high strength, high temp fiberglass, and then the carbon fiber. What's really interesting to note here, and I'll come back to this later in the presentation, is look at how this line matches up with 6061 aluminum. So for basically, when you apply the carbon fiber into these Markforged parts, you can get parts that are as strong as aluminum, and we'll see how you can do that later on. So that's quite incredible. So let's talk about some of the use cases and how people are using this. So our first example comes from Humanetics, and this is a company that designs anthropomorphic test devices, also known as crash test dummies. So they were previously machining their parts out of silicone. So that is a very time-consuming process. You have to do each one by one. And they wanted to switch over to a molding process. Now, the molding process required high clamping forces and sustained temperatures of 105 degrees Celsius. So they needed a material that can take the heat and the pressure. So what they did was they used a Markforged printer and the Onyx material, as well as the high strength, high temp fiberglass. And basically they printed it and we can see that the onyx has a heat deflection temperature of 145 Celsius and fiberglass, the high strength, high temp fiberglass of 150 degrees. So they were able to 3D print this part and have it stand up to their temperatures and pressures. And by doing that, they saved so much time from machining this. You can see their fabrication time went from 144 hours down to 60 hours, which is cutting it down below half the time. And then the fabrication cost was basically a quarter. So they went from $1,000 fabricating this part to 240 bucks. So you can see really incredible cost and time savings using this these printed parts. And you look at this part, you say, well, that could be machined out of aluminum. Absolutely, it can. And we're going to see over and over again how using the Markforged solution can relieve your machinist of time spent on the machine and reduce machining costs. So why machine something when you can 3D print it? You don't have to have a specialized operator running the machine. It saves you time, saves you money, and makes your business run faster. So the next case we'll look at comes from Columbia. Now, Columbia Electronics is a Swedish manufacturer of complete test fixturing solutions for the Nordic electronics industry. And they design snap fit fixtures to hold electronic components during their testing. So previously they were making their parts, either machining them or they were outsourcing the 3D printing. The problem with that is that machining the parts in-house took away time from their machinists, and with the machines they had, it limited the geometries that they could come up with, right? The other problem too was when they would outsource their parts, they wouldn't come back super great. So there are plenty of 3D printers out there that are capable of using electrostatic dissipative materials. However, they're not the best quality. Columbia was finding that they had poor surface finish, poor overall quality. So what they did was they purchased a Markforged machine and they printed this using their Onyx ESD. The Markforged machines have excellent surface finish, excellent accuracy, better than 10 thou tolerances. And what that did was they were able to bring all of this in-house, no longer needed to machine or outsource their prints. So of course that reduced their labor, their costs, and it sped up the product development cycle. So a great example of how 3D printing can give you the competitive advantage there. Next example comes from Cabin Management Solutions. So they design and manufacture cabin in-flight entertainment systems for business and private aircraft. They do a lot of retrofits as well. And what they did was they replaced traditionally manufactured parts with the Markforged 3D printed parts for some of their low volume, high value luxury cabin parts, like the in-flight entertainment retrofits. So this cut down on their lead times quite a bit. And the material they used was the Onyx flame retardant, which is UL 94V0 flame rated, which is compliant with some of the federal aviation regulations needed for aircraft seats. So this is a great example of a material that can be used as an end-use part and cut down on your machining time and manufacturing time as well. The last example, and this is my favorite example here, is from Brooks. Brooks manufactures automation equipment that handles high precision, fragile products like semiconductor wafers. Now, like a lot of companies, they were using 3D printing, and 3D printing has been around for years and years and years. And they were making prototypes, but these prototypes were non-functional. And so basically they were able to maybe do some test fits or visual tests, but nothing that was actually usable. So they would basically, once they had their prototype that they were happy with, they would outsource it to get machined, week-long cycles to outsource this and get it fabricated. So what they did was they brought in-house the Markforged solution. And as I mentioned before, with the combination of carbon fiber and onyx, you're able to mimic the properties of 6061 aluminum, which is exactly what they did. So they went from just being able to 3D print test prototypes to actually 3D printing a final end-use product that they could use on their automation lines. So how does that happen? Well, we talked about here, you can see the stiffness of the carbon fiber matches, the the strength of carbon fiber matches 60, 61 up until its yielding point pretty much. And it's important to note that you have to properly route your fiber in order to achieve this. Now, using the Markforged solution is very simple. You don't need an experienced operator to do it. You just need to know a little tips and tricks, which I'll talk about now. So fiber routing, it's important to note that fiber is laid down in the XY plane as the part builds up in the Z direction. If you're familiar with FFF or FDM printing, you know what I'm talking about. Basically, you have a nozzle that's extruding plastic, goes layer by layer and builds up in the Z direction. So as we saw before, the fiber is laid down as each layer is printed, and the layer before it is not directly connected to the layer above it in terms of the fiber. It is all inside of one solid plastic part. But for that reason, you do have to consider some routing strategies. So it's important to note that fibers are strongest in tension. So you do want to consider your part orientation when you're designing your part, and then how you're going to route the fiber in the print preparation stage. So as I said, fibers and tension are the strongest. So if you're going to have something that's getting pulled on, you're going to want to align your fibers in the direction of the load. And these blue lines here represent the fiber. And we'll see what that looks like in the software later, but these blue lines represent your continuous strands of carbon fiber here. Now, if your part is bending, then whenever you have something bending, you typically have compression at the top, you have tension at the bottom, and since our fibers are strongest in tension, you're going to get a lot of strength from that carbon fiber there. So when you do have something that's being bent, you essentially want to make a carbon fiber sandwich. So you'll have some grouping of carbon fiber at the top of the part, as well as some groupings of carbon fiber at the bottom of the part, and that's going to give you really good results. And then another case would be if you have a part that's in compression, you're going to want to distribute that compressive load across the entire part. So by putting some concentric fiber around the edge of the part will help increase the strength of that. So there's a couple ways we can lay down the fiber in each layer. There's going to be the concentric fill, which I just mentioned. So in a compressive load, you may want to do the concentric fill that goes around the perimeter of the part, as well as around all the internal holes and cavities as well. So that's one way of doing it. The other way is going to be an isotropic fill. So the isotropic fill fills the entire layer of that slice, and it's going to alternate by 45 degrees each subsequent layer. So the fibers are going to have strength in pretty much any direction you pull on it. Now that seems like a lot of information and it may be tricky. Oh, how do I route the fiber? Well, thankfully, Markforged makes this technology super easy to implement. They do offer free software that comes with their printer. It's called Eiger, and it's a web-based platform that you don't even need to install it on your computer. It's running off the cloud. So all the processing is done on their servers. You don't need a fast computer at all. And it's as simple as dragging your part into the web browser, and all the settings are pretty much pre-configured for you. All you need to do is select your material, select whether or not you're going to be using fiber reinforcement, and then you select what type of machine you have. There are some other settings, just a couple other settings, but most people leave those at default, and it works great for pretty much everything. And over on the left-hand side here, it will tell you exactly how much material you're going to use, what the cost of that material will be, and the print time. And I found that all of these have been pretty darn accurate. So I go by these numbers, and I definitely trust them. So once you bring in your part to the Eiger software, you can choose how you want your fiber to be routed. So in this layer here, you can see this is a brake handle. And this is kind of going up along the Z direction here. So what they did was a sandwich that we talked about here. So we have carbon fiber at the bottom. It's not shown here, but another carbon fiber layer at the top. And for this, they did a concentric fiber. So it's just kind of routing around the edge here. And this is what that part looks like. So this part I just want to mention was stopped mid-print just so you could see what the internals look like. But basically, you're going to have your base onyx material, which makes up the most of the part. So that's that black material here. And then this one was routed with fiberglass. So you can see that concentric fiberglass going all the way around the part there. So it's a very simple process of simply dragging your part in, knowing a few tips and tricks on the best way to route your fiber based on your loads, and then hitting print. Everything on the Eiger software is web-based, including the printers. They do connect to Wi-Fi, so you can push your print to the printer. Even if you're not on the same network, you could be at your home and send the print to your office. As long as everything is online and it will monitor it for you, you can see how much material is left in the printer. It will notify you if there's anything, maybe like the material runs out, or when the print finishes, you get notified. So it's a very easy to use, friendly system, and you definitely don't need to be an expert to use it. And if you have any questions, Saratech is always here. I'm always available. And like I said, I live and breathe 3D printing. So I'm always happy to help you with your needs there. Now, I hope this overview has been very helpful to you guys. And this was just an overview of the exciting things you can do with the Markforged composite system. We talked about a lot of different materials like the onyx, the different types of fibers, the different variations of onyx. But believe it or not, we didn't cover all of the materials. There is still quite a bit of other thermoplastics that Markforged offers. And we hope to have another webinar at a later date so we can talk about some of their new materials like their flexible smooth TPU, which can be used for a lot of really cool things such as living hinges and flexible belts as well. They have a new low-cost precise PLA, so we can go back to that visual prototyping. Let's say we need to make several iterations of a part and we just want to get a visual and we don't necessarily need something strong. That precise PLA is going to be there as well. And then there's also an Ultim 9085, which is carbon fiber compatible, so you can make some very high strength, high temp parts. So we'll have another webinar on that, so definitely stay tuned. On top of all of these composite and thermoplastic machines, Markforged also offers a 3D metal printing solution, which is very affordable and very easy to use as well. So we're happy to discuss that at a future date.
It is great, Andrew, to learn how strong these parts are by incorporating continuous fiber. I'm amazed to see the fiber versus aluminum graph and how the printed continuous fiber performs, not only easing your supply chain bottlenecks, but also by adding speed by having this technology in-house. Let Saratech show you how you can shift the complexity of your system into the advanced technology of Markforged, really expanding your use of composite 3D printing when you need to swap in and get parts fast. I'm always excited to talk about 3D printing and manufacturing, so please give me a call anytime.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.